Hi everyone, I'm Jin Zhao, a PhD student at Brandeis University in computer science program with a focus on natural language processing. I study how language and AI interact. Today, I will tell you how I found my way into science and what I study now. I come from Chengdu, China, to United States in 2018, where I came here for my master's degree. I flew approximately 7,000 miles. Fun fact, my hometown Chengdu is also the hometown of pandas. My favorite activity back home was to go to panda research base to watch pandas eating bamboo shoots. Working there was like a second dream to me. So I grew up in Sichuan province, China, where my parents had moved for work. At home, we spoke their dialect, but at school, we used another. And in my neighborhood, people spoke a third. From a very young age, I was switching between three dialects every day. They are mutually intelligible, their phonetics differ significantly, even though their grammar is similar. Here is a map of languages spoken in China. So this is actually a very common phenomenon for kids to speak different languages in school and at home. At the time, I felt very normal. But later I realized that these languages weren't treated equally. People in the market would even raise the price of groceries for my parents because they spoke the local dialect with a very, very heavy accent. My parents' dialect was often looked down on. People judged them for how they spoke, not what they said. That really stuck with me. When I was in high school, I had no idea what I wanted to do with my life. In high school, my life was mostly studying for the college entrance exam, which is notoriously brutal among many East Asians. I didn't know what I liked. I just knew I had to study everything. Physics, chemistry, biology, and math, those are all the subjects that got tested in the college entrance exam. The good part is I did get a strong foundation in science and problem solving from the drilling and training in this time period. The bad part is I didn't have much time to really think about what really interested me. When I go to college, I chose to major in foreign languages, not computer science. I just want to quickly mention here my favorite novel and movie Arrival back then, where a linguist got to be a superhero who saved the world. This story actually made me think linguists are super cool and I wanted to be one. So in college, I took classes in teaching, linguistics, and literature. My curriculum included theoretical linguistics and sociolinguistics, where I learned about language structure and its social context, as well as courses in foreign languages and literature that deepened my understanding of cultural and historical dimensions of language. I also studied language acquisition and language education, exploring how people learn and teaching languages, along with the applied linguistics that connects the theory to the real-world use. That's also a typical curriculum in a foreign language department in a Chinese university. And for the first time, I learned about that you could study language as a system, why people speak differently, how society shapes the way we talk, and how power is embedded in everyday words. I became fascinated with sociolinguistics, how language reveals identity and the inequality. I did small projects collecting speech data and analyzing dialects. Those are all very fun research projects to me back then. But to be honest, linguistics didn't seem to like a good way to make money. So very pragmatically, I learned to code. I told myself programming is useful, it pays the job, it pays the bills. At first, I didn't really love it, but something surprising happened. I gradually realized that coding could helped me learn language in a very new way. It's a very, very powerful tool. I could collect thousands of articles, analyze word choices, and see patterns that humans alone just couldn't see. There are so many news articles, so many language information popping up every day, and people only have that much resource. So we need to, so computer is a very powerful tool. So I went into a master's program in computational linguistics after I've done some data processing and programming work. I studied computer science, engineering, and advanced mathematics, which equipped me with strong analytical and problem-solving skills. Courses in artificial intelligence, machine learning, and natural language processing deepened my understanding of how algorithms learn from data and how languages can be modeled computationally. Together, those classes really prepared me to bridge the theoretical knowledge of linguistics with practical applications in building intelligent language technologies, like ChatGPT today. So that's how I ended up in computer science. Not because I planned it, it's because I found a bridge between the two worlds I care about, language and technology. So today, I study computational framing. Essentially, that's how language shapes the way we perceive news and events. I read bilingual social media almost every day, and it's disheartening to see how people live in their own information bubbles. My parents, my Chinese-speaking friends, and my English-speaking friends here are all equally intelligent and kind people, yet they often hold drastically different views on many events. That contrast really struck me. So, what is framing? Imagine reading two different news headlines about the same climate event. One says activists bravely protest climate inaction, while the other says radicals disrupt city over climate agenda. Same event, but vastly different images painted in our mind. To get a full picture of climate change, we humans might read dozens of articles and notice some recurring themes. Maybe 3 of them are talking about the peaceful protest, but 2 of them talking about the looting and the chaos during the protest. But is that the real picture? How can we analyze millions of articles from tens of thousands of media sources in thousands of languages without drowning in words every day? That's where computational framing comes in. We use deep learning methods to cluster equivalent events and detect hidden narrative structures in texts. By teaching computers to recognize implicit causes and underlying agenda, we can identify how certain topics are consistently framed over time and across different platforms. So the large language models we call LLM we use is trained on an amount of data that would take a human 7,000 years of continuous reading to complete. The clusters of neurons and weighted connections in the middle image here represents the way LLMs learn and store information. We tune such an LLM with supervised fine-tuning and reinforcement learning to automatically detect the framing or the perspectives we mentioned earlier in the news texts automatically. Now, I'm going to use this web prototype to illustrate our pipeline systems, what our systems and models do exactly. Here is a screenshot. So you can type in any news event that you're interested in here. Now I will illustrate our pipeline with a case study, Putin's 2024 election win. So on the left, you'll see an excerpt of a news article talking about Putin's election win from one media. And on the right, you'll see an excerpt of a news article talking about the same event, Putin's election win, from another news media. So our model extracts all the events from the paragraphs, and they are highlighted as green here. As you can imagine, people around the world talking about Putin's election win very differently. But how differently, and how do we teach computers to recognize those differences? So our model first cluster all the coreferential events, meaning the events highlighted with the same color here refers to the same real-world event. For example, all the pink text, like claimed history, win, and the re-elected, and the victory here across two articles all refers to the same real-world event, so Putin's election win. For another example here, the highlighted green text here, the extending his rule, control, grip on power of Russia on the left, and on the right, the stewardship of the economy. The words are very different, but we know that all of those events are talking about the same real-world event, which is Putin's leadership of Russia. But as you can see, there is this contrast here, even in the word level, that can tell you, obviously, which author here supports Putin's election win and which doesn't approve. Our model also gives all the unique events only appears in one article. For example, only the article on the left mentioned ballot stuffing and intimidation, and only the article on the right mentioned the improvements of infrastructure. So this is very intuitive. If the author supports Putin's election win, they would describe more about the improvements in Russia's economy, and if people are skeptical about Putin's election win, they will suspect whether the election was rigged or not. So this is a very classic example of emphasize and omitting certain facts very deliberately. And framing is not just about factuality. Actually, those can both be factually true. It's just how the author chooses which aspect to emphasize. Our model also extracts all the causal relationships. For example, the article on the left indicates that disqualification of candidates is probably a reason of victory, while on the right, the successful stewardship is the reason of the victory. And the model extracts all the causal relations in every article. And this is just one example. In our website, you can actually clicking on the list and see every causal relationships appears in those articles. Okay, so that's a very brief preview of my research. So this approach can rapidly sift through massive volumes of news articles, highlighting exactly how different media sources portray the same event, and this can spot emerging frames with accuracy and speed. So why does this matter? In an age dominated by information overload, polarization, and misinformation, understanding framing isn't just academic. It's essential for informed decision-making for everybody. So our system, we hopefully can equip the journalists, policymakers, and everyday readers like you and me and my friends back home and my friends here with powerful tools to see through bias and better understand the nuance of the truth behind the story. So apparently here, Putin is not seen as evil in every part of the world. Some people actually trust him, and some people have some skeptical views about this event. Through AI, we're stepping closer to a media landscape where the fairness and transparency aren't just ideals. They can be measured and they can be achieved. We don't want to tell people whether Putin is evil or not. We just want to show all the perspectives and the framings that appear in the articles around the world across different medias and across different languages. At last, I want to say that I didn't plan my career. I followed the questions that matter to me the most. How and why do people speak about the same thing very differently? You don't have to know your dream job now. Just stay curious and let that curiosity guide you.